first nano satellite mission in the INSPIRE program. It recently was thrown into orbit, and we had a discussion about this earlier. Today is a special session because this time we would like to have a very candid discussion with the students involved in this. As you know, InspireSat program is a very global initiative which has collaborations from many universities like NTU Singapore, NCU Taiwan. Then we also have the University of Colorado and of course IIST in Trivandrum. All of our guests today are from the Indian Institute of Space Science and Technology Trivandrum, who have played a significant role in the InspireSat 1 project. In addition to this, there were many other people who have contributed a lot to this project as well. And we couldn't unfortunately speak to all of them. So it would be great if you guys first introduce yourself and tell us what you have done on the project. And then we can also call out a few of the other people who you think need to be mentioned, without whom this project wouldn't have been the success it is now.
Yeah. So I'll start. My name is Anand, and I was working on InspireSat since second year. And I have mainly been working on the command and data handling, or the onboard computer subsystem of the InspireSat 1, as well as recently towards the data telemetry decoding and analysis parts.
So yes, I guess I'll go next. I'm Ankit Verma. So I also started working on Inspire 2017 in my second year, along with the other people who are also here, like Kostu and Anand. So I worked on the CNDH hardware side, then mission design and EPS system also. And finally, spacecraft integration later on once we had other subsystems fabricated and stuff.
So, hello, myself Devashish Bhalla, and I was involved in InspireSat project since 2021, and I was majorly responsible for satellite launch vehicle integration, and it was a wonderful experience.
I am Dhruva Anand. I have been working on InspireSat since my third year, that is 2021. We came in amidst the pandemic and started working on this. Right now, I and Aroshish are commanding the satellite from the ground station of IIST.
So I'll go next. I am Kaustubh. So currently I'm in URSC like since 4 years. So I think we were the first batch who joined like InspireSat as students of IIST. For InspireSat, I worked for around 2 years, starting from my internship of the third year. Before that, I was working for like not a very well organized program, but it was called IIST Nanosat that time. So we started that time and then joined through the InspireSat and then moved along.
Yeah, so I started working on this 2017. As just like also I also joined into the Nanosat program first via IIST Nanosat. Then in 2017, I think somewhere in like first quarter or something, we were told to design the CNDH for our InspireSat. That is when me and two other batchmates of mine, we all joined together along with Kostu and our senior Nivashni. So 5 of us were there. In 2017, we started working on that. So during that, of course, Priyadarshan were guiding us all along. But at the same time, all of us were working on this for the very first time. IIST hadn't flown any nanosatellite as such up till then. So we all were working. Of course, as Kostu mentioned, that we already had some design for CNDH from our seniors, which we used as reference to understand the processor we are using, to find out which pin of the processor does what, and what can we do with that processor, what do we need to give to other subsystems of the satellite, and then try to lay out the pins and give those signals.
The InspireSat 1 came here as a package. It was a complete satellite. It wasn't bits and pieces like how Ankit, Kaustubh or Anand have seen it. It was a complete package satellite which had its firmware, various interfaces were tested. It was almost a complete system on its own. Now, when we got the satellite, it was pretty exciting. We had another sir here, his name is Mayuresh, and he was the one who helped us out understand the satellite altogether. Aroshish, I and Aman, all three of us were constantly interacting with him. It was a very great experience to learn directly from Mayuresh sir, because he has been a tremendous motivation for us and he is one of the biggest embedded system engineers that we saw. Then later on, it came to our hands to integrate the satellite with the ground station. So IIST has its own ground station where we have a UHF, telemetry and telecommand capability. And also we have an S-band dish antenna, which was set up when we were here. All our sweat, tears, and blood were in that. We also tried to put it up and integrate it with the satellite. So the satellite was here at our laboratory. We were constantly testing it day in and day out. So all the process involved interacting with various professionals from around the globe. As Anant, Ankit, and Kaustubh mentioned, we were also interacting with the LASP team constantly, and also with the various members at LASP, and also from Mayuresh sir, because they have been the major driving force behind this, and they have helped us understand the satellite as a whole. So as an operator of the satellite, we need to know how the satellite works, what command should be sent at what point of time, and we should know how the satellite will behave after the command is sent. So all these things are like a huge handbook to be learned. It's like around, you can say it's like a huge data sheet. How Ankit and Kaustubh were reading through that, whatever ball grid arrays data sheet is, we had to learn all of those things here also. From there on, the satellite integration was to be performed to the PSLV. I and Aroshish and Aman were very involved in the software parts of it, like how to control the satellite, how to handle it. And Devashish was taken up to be the lead for the satellite integration with the launch vehicle. Maybe now I'll just pass it on to there so that he can elaborate the experience.
Yeah, thank you, Druva. So actually, I got into this project at 2021, as I told. So initially, like, I guess I am the only one here from aerospace background. Rest all are avionics. So like, call was made that IWL, there is one deployer, IWL 150V2, which is developed by ISRO. So that deployer was to be used for deploying the InspireSat 1 away, or like from the PSLV stage 4. So what my initial job was to like handle the fit test for the deployer, and like there was a team from MBIT which came to IIST at space, and therein we had to interact with all of them. So there was like a bunch of people here, and we have to interact with all of them. They can ask you anything about the satellite structure, about where what is placed where, and why this particular thermal reflector is placed here and all. So that and all I have to get myself acquainted with. And after that, we actually after the fit test was successful, so we waited for the launch. And as we were told that launch was supposed to happen in December, so we were pretty much pumped up, but that didn't happen and launch was delayed. So for we had to wait till the integration was over, and we went for the integration at SHAR. So there, what happened was there was a series of tests to be conducted on the satellite, known as comprehensive performance test, and some other startup tests also, to make sure that satellite is perfectly fit and electrically as well as mechanically to launch. So therein, Dhruva, Aroshish, and Aman, they were actually conducting electrical tests, checking the battery, charging of the satellite, and I was the quality assurance for that task. And then on, I guess it was 6th February, I guess, there we had to go for integration. So we had to climb up the PSLV. So it's like a 41-meter tall structure. You need to actually climb up. And once we actually got into the building, the building name is SP3. So once we got into the building, we were like, okay, where is the rocket? Where is the rocket? So actually we were standing behind the umbilical tower, so we didn't see the rocket. So then we actually climbed up. We went in front, slide front internally. So then we saw the rocket, and it was like, oh my God, what is this? So thing is, we actually saw the rocket in photos only, right? So once you actually stand in front of it and you see it, it is entirely different. And then actually Druva went up, there was a shift. So Druva had to go up to put the satellite, because we had packed the satellite in a Pelican case, and there was a clean room. So clean room actually is where you actually control, particulate matter quantity and temperature and humidity of a particular room. So they were actually establishing the clean room at stage 4 and the top of the building, top of PSLV. So we were at the bottom. So Druva actually went to top, and I was there. And with me, Aman, Aroshish, and there was Priyadarshan sir, Umesh sir, Chakravarti sir, and Joji sir, Suhail Bhaiya. We were all there. So initially we were not allowed to go close to the rocket. So what we did was we actually waited. Then some personnel came. We asked them, "Can we go?" So they were like, "Come on, we'll show you." So we went there, and when you touch the rocket, it is very, very exciting. And then what happened was, so that person, that personnel was like, "Okay, climb up the stairs. I'll show you inside the rocket." I was like, "Oh my god." Then we actually climbed up the stairs. So what we saw was, like, internally, though, there is PS1 nozzle, right? So that is a solid motor. So there is a nozzle inside. So what they have done is they've covered the nozzle with a cylindrical strut. So what we had to do is, there was an opening inside, and they were actually going inside, and they were routing all the harnesses. So we actually went inside and saw it. Oh my god, it was so good. And then that day only we had to go up to PSLV. So we had to go and get wear those ESD codes and hats, so as to enter the clean room. So when we enter the clean room, then we actually initial. I'm just painting a picture here. So when we entered the clean room, it was completely white, and when we saw this, and there was this big PSLV pairing standing placed right at the entrance. And then we actually went in, and there at the center was the PSLV stage 4. So then there was a set of tasks coordinated with the MBIT team, and there was a integration team from SDSC Shar also. So then the day spent, and we actually spent around 8 to 9 hours there, and turn by turn we were actually coordinating all the activities and integrating the satellite. And then at last, me and Dhruva, Aroshish, and Aman, we were there, and Akash Mahobe was also there, and we actually placed the satellite over the top of the stage 4, and they actually integrated it. So there was a slight anomaly there. Actually, there was no clearance for one fastener to be placed, so it took a lot of time for us to get it done. But yeah, so then actually we completed all the tasks. We came back. And after that, next task was, I guess, launch. So that was a very great day. I guess Aroshish can also mention something before we move ahead.
So hello, yeah. So basically, after that, we had the launch day, a beautiful day. We saw the launch on camera. The launch was beautiful. After that, we were able to see the separation. The separation was kind of stable, just because of the new modified IWL V2 version, I guess. So we didn't face much detumbling after that. After that, the first pass was over last. So basically, we were able to receive beacons, and satellite was basically in safe mode. It was power positive, and everything was fine. We were very happy. Then it came over IIST after a few hours. Then we were also able to receive beacons, and the best thing was we were also able to upload some commands. So that was the happiest experience, getting everything done in the first pass itself, having a proper communication with satellite. Then day passed, we had some ups and downs with communication. We faced some problem, but yeah, we did everything. There was other commissioning steps also, commissioning ADCS, the comms, getting the beacon data. Day by day we were doing one thing or another and for now we are at the end of the commissioning process. We just now today itself we set the ADCS to fine pointing mode, is pointing towards sun, and the next step will be basically turning on the S-band, doing the S-band test. After that, basically the satellite will be self-reliable. We just have to downlink the payload data. So yeah, we are just about to end the commissioning phase. After that, satellite is on its own. We just have to keep on checking so that there's no problem in that end. That's all.
And then we got the first spectrum from space. That was a miracle moment for all of us, where we saw the first very clear spectrum that the payload's working. And I think we correlated it a lot. We were so happy that day. And right now we are dumping a spectrum every day. So we just have spectrums daily. And yeah. I just wanted to ask Kaustubh and Ankit, for instance, how was the starting of this whole thing? I mean, so you guys mentioned that you guys started with this whole like when the whole program was taking shape and so on, right? So I mean, when you had to kind of interact with international teams and then kind of put together the whole idea of a satellite, I mean, how does this actually go by, and what does a human, like a student satellite look like? I mean, did you actually know basically that this is what you were signing up for, and did you actually understand that will go this far? You know?
Yeah, I think Kaustubh was present at the inception of the Inspire mission and the structure of it. So I think, yeah, he should go first to answer this.
Okay. So to answer the first part of the question, like how was it to like interact with international teams and then like build a spacecraft from the scratch. So yeah, like so I like what I can recall is like first of all there was a solid interest, right, from like the basic structure was that they wanted to have a satellite program. That was point number one. Point number two was it was supposed to be like a consortium kind of thing, like where you identify nodal centers which have expertise in maybe different aspects of satellite building, and then you pool the resources. So it's not like one particular team is coming up with the entire thing and then it's like a credit sharing or something like that. So in this kind of scheme, essentially what you need to understand, or at least what I can say, what we did was it was we had a brainstorming session in the first workshop at NCU. So everybody came up with like areas in which they are particularly like they have developed an expertise over a period of time. So in that sense, like the last team, they were really good with like the infrastructure for spacecraft building. They had excellent labs. They have had like great like spacecraft programs in the past. So they had all the testing facilities and like it essentially the infrastructure as such. Then like what we were experiencing at that time was we had individual student projects till that point in time. So we had expertise in the C and DS card. So there were like our seniors who were working on that. So we had proposed
so
that.
Just to ask this question, Queen, I mean, what exactly are these subsystems? So you mentioned the CNDS card. I mean, what exactly is this supposed to be? And can you just briefly also mention about what these cards are, like as a general science student, because it's a bit difficult to understand with the background that you come from and with the background that we come from.
Okay, like it can be XYZ, man, anything. Like it's just that there are like people who are dealing with different things. So okay, essentially what CNDH it's like a command and data handling card. So we have an FPGA unit built inside, and it essentially generates the control signals for all the different subsystems, synchronizing them, and like giving them commands as to what to do in which point of spacecraft operation. So it's like one of the most important parts. Like in layman terms, you can call it like a brain of the satellite and something like that. So and the skills involved in that were mostly first of all, we need to have that RTL development of different blocks which we wanted to embed in the FPGA and that part, and then an understanding of all the different kinds of functions which the other subsystems are doing, so that we can generate the control signals for them. So these were more or less the.
So basically, you kind of have to have a picture of the whole satellite while you're building something like this, right?
Yeah, so that is the role of the CNDS card. Actually, Ankit was greatly involved in the development of it, so maybe Ankit can like shed more light on that. But essentially that was more like FPGA coding, and then like embedded system. Like the skills involved were related to like embedded software, and then like RTL development, and then like understanding of the interfaces, the bus protocols, like things like that.
Okay, thanks a lot. I mean, this kind of paints a clear picture of how much you need to plan before you actually start with this, right? Because you need to have a complete idea of who's going to take what, and especially if you're working in an international team, it kind of makes a lot more sense to kind of divide these ideas and so on.
and to kind of work on it also collaboratively. So Ankit, do you want to mention about how did you guys kind of put this together when you had this whole thing? Now basically Kostu has mentioned how they like came up with a white paper essentially. And then when you are working on this, and you also have to take care of the fact that like designing an FPGA in a general environment is one thing. The other part is to actually design it and have it something that can float into space, right? It has millions of different sort of requirements going on to it. So how do you kind of accommodate both of those things together? Like being a student specifically is something that we really are interested in.
Yeah, so as Kostu mentioned, CNDH is kind of a brain of the satellite. So obviously there is a processor sitting in there. And in our case, the processor was part of our FPGA. FPGA is just fancy word for something, basically a word for kind of processors, whose hardware you can reprogram just by programming from your computer. So anyway, so as you said, the environment here and obviously in space are very so differently. We have to take care of various scenarios like high energy particles and all those things, heating up of the processor. How do you make sure it is not overheating? Because there's no air or anything like that. Only radiation and conduction is the only way of getting the heat out.
So you can't use the fan.
Sorry?
So you can't use the fan essentially.
Yeah, sadly not, unless we do some environmental control on board. But that is not going to happen anytime soon. So once we started with our design of our CNDH, taking the account of these things led to the selection of very specific kind of parts. For example, in the case of processor, we knew the kind of processor we are using has been tested for this radiation level, and it seems like it will be able to withstand the radiation level on board. Then now what about the heat? So we thought, okay, what we know how the IC will be sitting on on our card. So we can ask our structure team to run the thermal cooler so that it can remove the heat via conduction and dump it on the structure of the spacecraft, which has much more thermal capacity. Then we were worried about, because it's the brain of the satellite, so you have to make sure even if any other parts of the satellite goes wrong, it should not affect your brain, obviously, just like our as a human being. So we need to develop a lot of protection designs around our processor. What if we get a very bad signal from this kind of subsystem? What if we get very high voltage from this system, which we are not expecting? We don't want the smoke coming out of our CNDH, obviously. So designing those protection units around our CNDH was kind of a major task for us. And a lot of time and energy was spent on that part. So you can imagine, I mean, this is a very unique feature of the space program, right? Not only you design a system, but you have to deal with harsh environments, and you have to develop these protection units, not only for CNDH, but the subsystems, so that they do not affect each other, so that the failure do not propagate from one system to another. During this, yes.
Just one question that I had: do we understand this correctly? That these subsystems are basically to be used in all the spacecrafts that go to the space, right? So are there not really like customized solutions that are developed already, or do you have to always kind of start from scratch or develop like every time a modular solution for your own problem?
So as for the when you're saying already existing solutions for that, so coming to getting a specific example of our CNDH. So we knew that first you have to find out what are the problems you're trying to target to develop the protection system. And then obviously you go on and do your research and do your survey if already some solution exists. And then will it be helpful for you or not? But because each satellite is very specific in its own design, especially the nanosatellite, because they are miniature, you have miniature components, you have more constraint on mass, volume, and all those things. So the conventional methods of protecting any unit may not be applicable directly on your particular subsystem of your satellite which you're trying to develop. In that case, that's where imagination and creativity comes in. And then you brainstorm, go to the whiteboard and with your team, talk, discuss out, put different solution ideas and see what may work and if it's applicable or not here. So that's how we have been approaching, even though it is really great to have a standard set of solutions, but it just so far we have not come across. And I personally have not been able to think of any standard set of solutions for a different kind of problem, because as I said, each satellite may be very unique in its own. and have a different set of problems and constraints when it comes to temperature, radiation level, shielding, all those things.
Usually when we see it in popular culture sort of movies, we know that there is like a station, like super smart space station sort of a thing, and there's nothing else that goes on. I mean, everything is only on the satellite. So how does like having a ground station work, and what is exactly required to actually develop that or build that in a way? I mean, I think we're also going to be talking about it in another one of these episodes in Inklings, but I mean, how did you guys as students kind of take hold of something like that?
Yeah, I think.
Isn't it daunting to kind of literally do experiments on a satellite which is going up?
Yes, it is quite an interesting thing. Imagine you have a thing in space and you're playing with it. So how cool is it? I don't think many people get that chance. And at IIST, I think the setup of ground station was done by Joji sir and Ravindranath sir. We learn about every subsystem. We understand how each subsystem works with each other. That was the foundation of where we got the basics set. From there on, we tried to develop and understand various RF things. I would just say some fun facts, like to say how complicated it is. You can see a 300 watt power amplifier just by your side, and we were just measuring how much radiation are we exposed to from this little guy there. It was pretty huge. Like, we shouldn't be operating it in an open environment, but still we just try to play around with it. We send commands every day. We just it is such a exciting thing to do that.
Yeah, I also want to just so when Ankit, Anand and Kaustubh were working, well, during the launch they were kind of done with the graduation, but you people are still learning. So probably these three might have learned a lot, but Devashish and Druva, you are just learning. So was it scary that you did not finish your entire coursework of BTech, but you're handling a satellite?
See, satellite is $1 million thing. It's not a small thing, and you are interacting with people like they're like even a Chandrayaan. If you see, there are 10,000 scientists at ISRO who are working to get it done, and you are being a student. You are interacting with those people. So there's a fear that what if I miss some information or I miscommunicated something that may result into other set of events. So those things, we had to, like, as Druva mentioned, we have to sit and we have to like go through all the documents side by side. We have to discuss among ourselves. Okay, this is what it is meaning. And then when the team from MVIT and like they're also at SHAR, we interact with people. So it is like assuming something and it being practical are entirely different things. So we can actually design anything. Like I am actually from a structures background. So structures as in means like we have a skeleton, right? That is holding our whole system together. So my job is to hold the satellite together. So therein, like it was like they were asking a spontaneous question of what is this? Why is this? Why is it put here? Why you didn't put it there? So like we are actually getting into this InspireSat at a very later stage. And like we had to think from starting design point of view, why did they put it this, why did they put this whole layer and all and all. So it was scary also, but yeah, it was adventurous and we had a great time with this. And yeah, as you told, learning is still on.
Again, jumping back just to tie the knot completely, I guess. Kaustubh, did you, when you were working on this first project and you were actually looking at people sort of discussing about this and so on, did you guys actually imagine that it would actually become a reality and it would actually be floating up in the space while you were proposing all of these things, or basically contesting that you can build?
Okay, that's a good question, man. But you never know, man. So while we were working for InspireSat, we didn't. Yeah, obviously, like it was a long-term project, right? We didn't expect it to go up in space the next year. But that's how you do any project, right? Like you do whatever best that you can at that point of time, depending on the situations, and then like yeah, you hope for the best, and then like prepare for the worst, I guess.
Are you guys actually feeling how many sort of legacies you've kind of inherited finally, and then you're actually working on it? I mean, basically,
absolutely.
Yeah.
It has been a tremendous journey for every one of us here. I must say the knowledge, it was organized and then transferred to us. That was the main thing that happened. Otherwise, we would be just clueless.
Yeah, exactly. I mean, that just sounds super enriching in a way. In the way how this project has been kind of led on generation after generation of students, despite the whole challenges in between, and of course the corona and all of those things that happen in between, unfortunately. So I mean, the sheer success of this system, or the whole satellite, actually is a truth in itself. Is there any other thing that you guys would like to add that was kind of monumental to your experience in a way, technically or otherwise, briefly? And probably we can close the session on those ends, because of course I understand that all of you have not interacted with all the generations of people. So it's just interesting to see all of you here, probably.
Yeah, speaking of the legacies passed down and all the generations you have interacted with, one more thing that we would like to really know about is what's next. There are more Inspire projects coming through, but you guys will eventually graduate. So how do you plan on transitioning everything you know and learn to the future generations to come so that they can carry on the work that you have done?
Yeah, so I guess I'll answer this. So thing is, there are a lot of projects happening now at ISpace. So there we have a complete 10-year roadmaps, in that there are around 9 missions coming up, and each mission is like very much revolutionary. And there are few missions that are, going to be the first one has ever done with a small satellite, maybe in India or around the globe. So those missions are currently being proposal stage. So what we do is we actually induct people at ISpace every year. So like second year onwards, we start inductions, and through inductions, we actually, what the major aim is, we actually give them slight exposure of slight taste of what they're going to experience. And we actually they ask them to give us proposal, as in if they are free to design a satellite, what they want, and how do they design it, and what all things constraint they should think of, so that they are actually having an idea of what all set of problems they are going to encounter in the future missions. And other than that, what we do is we actually teach them. We start giving them problem statement, and slightly involving them in the upcoming ongoing projects, so that by the time they are at our stage, they are actually self-sufficient, and we are producing future grade engineers, so they are also space grade and ready for further tasks. So that is how we are actually transitioning every time. And as you can see, now also we are actually in touch with such seniors, and so it's a constant thing. So we are always there, and like that projects evolve, and hopefully soon we'll be seeing next launch.
Yeah, I mean, just to pitch in, so the progress, as you can see from the generations, like when Kaustubh started, he basically said IIST will build OBC and EPS, and there was a bare minimum infrastructure at that time. To now, we have a full-fledged ground station, a full-fledged electronics lab, which is called S-Space, Small Spacecraft Payload and Application, that thing. And then to see the transition from nothing to now, where we I mean, our juniors are claiming that we'll have many more satellites to come, is truly amazing. And yes, we are on the way. We have the first satellite fully functional and in orbit. And even there, I would like to highlight most small satellites, and especially with student involvement, there have been many small satellites, but most of them haven't worked in space. So we can proudly say that since IIST's first small satellite has worked phenomenally, with the the science spectrum also coming recently and achieving most of its mission objectives. So yeah, that the legacy and the knowledge flow has been quite good.
Which I would like to point out here, not the technology aspect, but also the human aspect of working on these long duration missions. As Naman, I think you asked when me, Kostu, and others were working on it, we did not even know when will it fly, if it flies, and all those things. So keeping managing the mission is one thing, making sure you know what is your aim, and you don't sideways from your aim. But at the same time, keeping in the case of IIST, where working in a space is a voluntary thing to do. So keeping people interested, which I'm sure they are interested right now, because just now we had launched it, but 3-4 years from now, how do you make sure the upcoming batch of students are motivated enough there are people who will be dedicated, but you need to make sure that they are motivated enough to dedicate their time and effort into developing these new technologies we have. And that is where, the small talks and these small meetings, not just about, why this package is not working, but also about what is going on and what do you want to work, or how the things going, and just making sure they stay on their target, well motivated. Otherwise, it's very, because being a volunteer work, it is very easy for people to drop off if they are not motivated enough. So yeah.
So basically, the points of sustenance, right, of a program like this, where the students are kind of pushing things forward, makes a lot of sense. Yep. So yes, I think then we can wrap this up. Thanks a lot for being here, all of you. I mean, Kaustubh and Ankit and Anant, especially you guys, because you were, of course, super disjoined from this whole program for quite some time, I believe. And then, of course, Dhruva, Devashish, and Aroshish. I think Aroshish had to leave in between. But yeah, thanks a lot for taking the time. It was really, really nice. And we hope to see much more coming from this. And probably we'll have a next roundtable where we have probably a much larger group. And then there will be probably a next whole generation of students who will be also inspired by the same thing. So let's see. Thanks a lot, and hope to see you guys soon.
Thank you so much for
Thank you.
having us here.
Thank you, guys.